Okay, so this is the second day of our Unit 10 notes, the inverse trig. Yesterday you talked about some intervals called principal values. So the first thing I'd like you to do is complete the warm-up problems that are on your worksheet. Pause the video, and then when you come back, we'll go through the answers. So on your warm-up, the first thing it asked you to do was state the range for each of the following. So let's recall those little graphs from yesterday. So for sine, if you were to sketch its inverse, it would look something like this. And again, this has to be a function, which is why we're only graphing a little piece of it. So the range of this function is going to go from negative pi over 2 to pi over 2. For your cosine, it's going to go from 0 to pi. And tangent, it goes from negative pi over 2 to pi over 2, but it's not including the pi over 2 and negative pi over 2. It approaches those values because those would then be asymptotes, very much like when you have a tangent graph that you have asymptotes at pi over 2 and negative pi over 2. So we use these intervals when we answer questions like A and B. So when I'm evaluating the following, arc sine of negative root 2 over 2, that means I want to use this interval from negative pi over 2 to pi over 2. So in the interval from negative pi over 2 to pi over 2, what angle has a sine of negative root 2 over 2? And that would be negative pi over 4. Now, if you said 7 pi over 4, that is the correct location. However, your angle is not in the interval that we need to solve in. Okay, so you want to make sure that your angle falls into the interval for that function. So for tangent, root 3 over 3, what angle is where tangent would be root 3 over 3? Again, we're going to be between negative pi over 2 and pi over 2, so that's quadrants 1 and 4. So root 3 over 3 would be our pi over 6 angle, okay, because that would be where your sine value is smaller than your cosine value. Now this one, C and D are a little bit different because they have you not only do an inverse, but then do a function after that. So if I start here with the inverse cosine of 1, inverse cosine of 1 is 0. So then what am I doing? I'm taking the tangent of 0. So when I think about my ordered pairs on the unit circle at 0, tangent would be y over x. So that would be 0 over 1. So the tangent would be 0. This one here is saying, what is the tangent of inverse sine negative 1/2? So let's get the angle for inverse sine of negative 1/2. I'm in between negative pi over 2 and pi over 2, so that would give me an angle of negative pi over 6. But now I need the tangent of negative pi over 6, and the tangent of negative pi over 6 would be negative root 3 over 3. It's negative because this angle is in quadrant 4, and tangent's going to be negative in quadrant 4. Okay, so now getting into today, we're just going to build off of what we did yesterday. So a couple of things I want to make sure you're clear about. The difference between these questions. So first of all, if I said I want you to evaluate cosine of 3 pi over 4 compared to evaluating inverse cosine of negative root 2 over 2, these look really, really similar. Okay, but this question right here, when it says cosine of 3 pi over 4, 3 pi over 4 is an angle. And so what I'm asking you for is the ratio from the unit circle. So cosine of 3 pi over 4, I'd be looking for the x-coordinate with a reference angle of pi over 4 in quadrant 2. So, that would have an answer of negative root 2 over 2. Where this question, because it's an inverse just means that we're looking for an angle. So I want to know what angle between 0 and pi would be negative root, where the cosine would be negative root 2 over 2. And that would be 3 pi over 4. So they're similar, but they're different. These are inverses of each other. So this is asking for the ratio, okay, but the inverse is asking for an angle. Now these two, again, look very similar, and almost a lot of people would say are asking the same question. In a lot of ways they are. This is saying what angle has a cosine of 1/2. This is saying what angle has a cosine of 1/2. They are kind of saying the same thing. The difference is this one, the cosine inverse of 1/2, is restricted to the interval from 0 to pi. So this notation alone is telling me that this interval is what I'm using. Where here, this is saying, well, aren't there lots of angles that have a cosine equal to 1/2? Well, yeah, okay, because we know that cosine's 1/2 at pi over 3. We also know that cosine's 1/2 at 5 pi over 3. And then if we were to go around the circle multiple times, we would have many, many, many answers. So we would have an infinite number of answers for this problem. So when you see this notation, the inverse cosine, we have to use the intervals. Okay, if you don't see that notation, then you're going to assume you're solving over the set of all real numbers. So let's take a look. If I asked you for the cosine of inverse cosine of 1/2, so that would say, start with the angle. What angle has a cosine of 1/2? Again, we're in the interval from 0 to 180 because it's cosine. So between 0 and 180, the angle that has a cosine of 1/2 is pi over 3. So then we're going to say, all right, so what's the cosine of pi over 3? It's 1/2. Well, that's kind of nice. Does it always work like that, or they just kind of cancel each other out? Well, not really. Sometimes you have to be really careful about what quadrant you're in. So here we have cosine of pi over 3, and then we want the inverse of that. So kind of going back to what I was asking about before, or talking about before, this question here, because the cosine is out here, my answer is a ratio. Here, my inverse cosine's out here, so my final answer has to be an angle. Okay, we're going to start inside the parentheses. Cosine of 5 pi over 3. Cosine of 5 pi over 3 is going to be 1/2. Much like the first one, right? Well, now I want the inverse cosine of 1/2. Well, remember, inverse cosine is restricted to 0 to pi. Isn't 5 pi over 3 outside of that interval? So the answer is not going to be 5 pi over 3. So when I look at this, I have to say, well, between 0 and pi, what angle has a cosine of 1/2? And that angle's pi over 3. So sometimes you have to really, really think about the quadrant that you're in, as well as the answer. Is it going to be a angle, or is it going to be a ratio? Okay, so arc sine of sine 5 pi over 4. Start inside here, 5 pi over 4, the sine of 5 pi over 4. So reference angle is pi over 4. We're in quadrant 3. It's got to be negative. Okay, so that's going to be negative root 2 over 2. Then I want arc sine, which is the same as inverse sine, of negative root 2 over 2. Well, for sine, our interval is negative pi over 2 to pi over 2. So between negative pi over 2 and pi over 2, the angle that has a sine of negative root 2 over 2 is negative pi over 4. So again, you can see these are really different angles, okay? They're not even in the same quadrant. So you want to pay attention to where you're located when you do an inverse. For cosine, the inverse is 0 to pi. For sine, the inverse is negative pi over 2 to pi over 2. Okay, here's 4 problems I want you to try. So please pause the video and try these problems, and then start it up again when you have all 4 answers. Well, hopefully you had a chance to do all 4 of those. If you did, here's what it looks like. So inside the parentheses, we're going to do inverse tangent of negative root 3 over 3. That's negative pi over 6. We're doubling it, so it's negative pi over 3. And then the cosine of negative pi over 3 is 1/2. Again, work in the parentheses. Here we have inverse cosine of root 2 over 2. That's pi over 4. So pi over 4 minus pi over 2 is negative pi over 4. So cosine of negative pi over 4 is positive root 2 over 2.